morning, everybody. Um, Welcome back to the second B-Axis event. Very exciting to be here, and hope you guys like this event. So we're gonna start right now. So basically, we just draw a simple part, and we're gonna start like having like a review with the G173 inclined surface. And this is what I did. So pretty much simple part in brass. I just got it at the office, and I'm kind of I will say pretty much every programmer should be like picky with with numbers in their program. And I have to say every every of our machines and we should have like G173. So not because you don't have a not a B-axis, real B-axis machine, you cannot machining something with some angle or milling something with some angle. So you have the option and you have the code. It's just not so hard to get there. So I'm going to show you again how do I set up this part, how do I program this part, and let's stick with us and let's start with this. So basically, um, this is 30 degrees angle holes, and we're just doing like a flat and a spot drill and drill. At this time, we're using L220 type 8. Uh, and we're placing the tools on the GSE 3310. Can be done with the 3210 tool, can be done many ways. So, so basically, I just want to have this print so that way you guys will understand where the numbers came from. And basically, if you don't have CAD software or something, this is made of by hand. It's handy program. And this is the way that I calculate for my turning, just to know um, where are my datum reference for my fixture on my turning. Then, because once you turn an angle at 30 degrees, you remove some material, right? So then I did my calculations for my milling, and this is what I got. So pretty much there's some of these numbers that will be on my G173 example. So I just want to make sure that you see it and understand where the numbers came from. So let's keep continue. So I told you before that I'm going to show again how to set it up the part using the G173. MC data need to be properly set, and you need to use slant. As you see here, I got machining data. This is a screenshot take from our machine, and it's pretty easy. All you have to do is just go control parameters, and all you have to do is just flip one of those parameters to one that says screenshot, and then you will press shift and you will grab this nice pictures. So anyway, so once you set up a slant helical, you ensure that it's showing you that you have that holder at an angle. So I have questions before that. How do I touch up the tool? So you don't have to touch up nothing. All you need to do is just have slant helical, and as you see here, tool 11, tool 12, 13, everything is as 0. The way that this is set it up, so you will see a little bit more in different slides, but just want to make sure that all you have to do is just set it up as slant and have everything as 0. I'm hoping you understand. So once I have my setting as MC data, which MC data, it's really important to all or any of our programs. Now this becomes, I will say, the first setting, like a visual at the machine. So you have that scale, and you need to pretty much, you will see pointing this white thing at 30 degrees. So this will be my first setting, and my second setting, I will call my second setting because I have another one. So I will tram my dial indicator against my holder using my sub spindle and using a magnet base with a dial indicator. But before to get to the MDI and make my dummy program, I will call, you need to do some math. So I will have in here, I will draw this little right triangle. I will have 30 degrees, and I'm having down here 1.5 inches, as you see here. So once you make all those calculations, so you will get 1.732, but in real it will be 0.866. It's just you have to double because at the machine will be diameter. It's simple as that. So once you got that calculation, all you have to just plug that on MDI, and you will see I have a small video here. So hold on a second. Why it's not moving? Hold on a second. I got some. Nope. Oops. So why is not? I'm just trying to play the video. Sorry for that. So as you see now, I'm just trimming using that simple programming. This is the way that I will teach everybody just to get the exact angle on any holder. I will use the machine and take advantage and let the machine work for me, not me for the machine, just machine work for me. This is as you see at MDI. So the machine will go, I will say, at the angle up and down, and M99, so it will be like looping over and over until I get the right angle. There's one comment that I will say here. There's another way to do it. So I love to use trick, but there's some people will maybe will not. So instead of having U, you can also use A, which angle. Cincom user know how to use A, so it will be A minus 30, and here too, it will be A minus 30. So there's two ways to do this alignment, or I don't want to call alignment, I will call get the right angle for our setup for this part. So after that, as you see, we got the GSE 3310, and we got different tools, stick out some different numbers. So the way that I actually make the calculations, I will measure from the cap knot, as you see here. So this distance will be the one, if you, I forgot to add just 110 here, but that will not affect that much. if you see first, the sine will be related on the U shift and cosine will be for the W shift. And it's involved that our 15 millimeter normal shift, and we can go from there. Also, there's some Excel tables that we have, and if somebody need to use and prefer that, all you have to do is just call us, and we will be glad to send that to anyone, or call the dealer. And also, I believe they should have it too, and they can send to anybody. So having this number, so I figure out, so my G50 will be the one that are on red. I'm not gonna start calculating trig here, but basically this is the example. I'm gonna go to the next slide. Uh, this will be my last step to make sure that I have the perfect angle on that holder. So at this time, I will check with the pin gauge. So kind of like simulating where is the angle on my tool, right? But first, you need to kind of like align the pin gauge around, like indicating, like I will say, like imagine like for your shock blade, and you gotta make sure that pin is right on center and it's not like bouncing around or wiggling around. Once you get that on center, then you got a same thing as a holder, just tramming against that surface using the same NDI calculation that I just showed previously. And if you see here, this dial indicator is like 110. So this will confirm that you got the right setup. It's at 30 degrees. There's some, this is just pointing out if you want to get it right. I noticed that there's some others, I would say, opinions, suggestions, like using like a combination square, but honest to me, this is the way that I will know I will get this perfect, no doubt. And I just want to show you guys, this is the way that me as a citizen, I will show how to set any holder. Even though this will work, let's say like a whirling hat, you can use this same method just to get the right helix angle on the drag whirl. All right, so let's keep going. So once we get all those settings, I just add here like will be the milling the flat, then the spot, then the drill, and I'm gonna keep going with the video that we have, simple part. And basically at the first time we have our U shift, W shift for our end mill. Regardless the 751 seek out from the cap knot. Basically on the end mill, I'm not using G173, just up and down in Y. I'm hoping and I believe that everybody knows that once you work at this point.
Hey Ray, you're cutting out a little bit there. Just kill the sound on the video if you're going to talk over it.
Okay, hold on. All right. Now, better?
Perfect.
Right, sorry for that, guys. So, once again, the flat is just not made of G173. So basically, then we start with the spot. The spot drill will have a different number, different amounts stick out from the cap knot, as you see here. Hold on a second. Let me use. I like to use the pointer. So the flat mill, the end mill, sorry, will be 751. Stick out. Spot drill will be 980, and the drill, it's like an inch and 10,000. So base of that, you need, if you notice, you will see our G50s. They're different, and the reason that all are different is just because different amount or lengths on our plan. Uh, Basically, and also, if as you see, the G173 will have 0.356, Z75, D30, which is our angle, and as you see on the drill will be the same thing. I want to point out as G173, Joe, I'm gonna go to the first slide just to show people. Hold on a second. I think this is the way. If you see, we got 356 on our G73. After we turn, we got, and it's here, we got again our trig calculations. We got 75. That will be on C, and the D will be 30. So I'm hoping I'm getting there and everybody understand what I'm saying. So let's go back again. So these are the point that we get from the print, and in the G173, then you got a G50 again, and it will be because got to be on radial, and basically what we're doing here is just dividing by 2 our x, which is 0.178, and we're shifting minus our 75. Then the x0, y0, z minus 50, it will just move into the angle plane. Simple as that. Then the Z 0.065, it will be the spot drill. It's 90 degrees. So if I want to spot drill, I believe it was like 10 thou. So the whole, so I will have to put on my code half of the 90 degrees. So that's what I have, 65. I believe it's 130. Yes, 130. That we want to spot drill. So then just retract back and then index 180 and do the same thing again. Then just canceling our shift, canceling the G173, and then cancel our main offset we have for our tool. The same thing will be on the drill. I don't think I have to explain that much. It's just over and over the same format again. At this point, I used G83. And the cool thing with G83, you can you don't have to do much math. You can just increase the Z and it will go more and more. Also, I made twice and repeat the G83, but you can use K2 and the H just to index, and it will work. It's just different ways to do it. So after that, I think I'm gonna move forward. I wonder if anybody have any questions about the G173, about the setup, how to line up the holder. Any questions so far, Joe?
Hey, Ray, no questions so far.
Okay, so I'm gonna keep going. All right, so now we, in the previous presentation, we speak about pretty much all the G codes that involve B axis. and it went kind of like I will say like pretty basic on that time, and I will encourage everybody to use G900, G950, G930, G920, and the reason why is because you don't have to G50. Um, it will the code will take care of that. So, but there's some other users that I know, and once in a while I will use it too. But I would rather use the real ones instead of just simple indexing. So, talking about the G910, it's just index. That's it. Index the B-axis, that like just tilting any angle you want. So I have made this macro subprogram just to help some people that they say like we gotta do many stuff, and is there a way that we don't have to go on all of that? And yeah, there's a way. So we make like a subroutine, and I think it's not that hard, but probably, and if any question over these, stop me, because this is gonna get pretty, maybe a little bit complex. So having the subroutine, and I'm gonna say it again, this is just to use on G910. And this is made off on the M70 control, made of the L32, and it can work on L20, but it will not work on the M800 control. It will be so different, way different. So um, using local variables, I just decide just to have that subroutine and let the machine pick the U shift and W shift for me instead of having hard time figuring out the numbers. So having this, so machine will do that for me. But you need to know how to do it. So 19, and if you see here, if pound 19 equals 0, go to 2. So it will go to here. It will jump to here. If pound 19 equal to 1, go to 1. So with N1, N2 means shift on, shift off. Basically, the G50, U25030 plus 4120, this is just grabbing the numbers from the custom variables in our machine. So I have that here, and pretty much 25030, it means it's honest, it's just a random number that pretty much I don't think nobody use. It's like it's a variable that is set as 0. That's it. Um, the 4120, it's like a tool function, and it will read which was the last or the tool call at that time. Then I have pound 101, 5022, and 5022 will be machine coordinate in Z. And basically what I'm doing there is just recording that position when I get there, so I can use it later on. Same thing with the 5042, but 5042 will be in real our workpiece coordinate in Z. So having the or using the G910 to make like a milling interp, because in this case we're doing like phase will be 0. So we need an M70 control. We need to use M211Y1, which is the mirror image on, and also we need to declare our G140 arbitrary axis exchange, and we got to say X0Y0, and you will see in the next slide why. Maybe we're gonna go back and forward. I want to show this. Let me go to the next one. So. Not that one. This one. Okay, this one. In this one, as you see, I have here calling up G65 P8110 S1. So S1 will be related on the 19, which is a local variable. And if you look under offset and you hit the soft key that says local variables, you will have like this. So that means X, the S. So having that, I'm calling up my shift and then just keep going. And in these three examples, we're doing like hex 0.7 flat to flat. And as you see, pretty much all the code are the same, except this one, it's milling interp. And this two is just using the machine as a milling. I'm not doing milling interp, it's just going all the way around the part. So having all those numbers, so once we finish, we have, again, we got to cancel the G50s and W or Z. And in these two examples, so we have the same thing, but in this one, it's milling interp. And as you see, using the same thing, using the same thing. And this is the reason that I will point out everybody to use the real stuff for the B-axis, G900, G950, again, G930, G920. The reason why, if you see with this code, I will do the same thing. I have that subroutine made. If you don't have that subroutine, then all that code that is on that subroutine should be here, need to be here. So I think it's a long way to go. So that's, again, we encourage and we like to show the real stuff. Well, people will like this, we can send it, that's not a problem, but we have choices. Any questions so far, Joe?
No questions so far, Ray. So far, so good.
Okay. So again, please analyze these three examples, and I believe at the end you will pick, and there will be the best way to go. The only thing with this 900, 950, 920, 930 milling interp, it will not be allowed. So you can use it, but you have to cancel before you go to the milling interp. So you need to add a little bit more if you're gonna use 12.1 on this one. All right, so probably you will feel, some people will feel this. If there's any question, please, I will be happy to answer. Again, Joe, no questions so far?
Nope, so far, so good.
Okay, let's keep going. So I make last week a part. There's no reason for this part. It's just to show something over this presentation. And this part I made off on the M532, and I use software Spree just to show how to use a Spree. I use for this example, I use a spiral roughing just to go around the roughing out the part, and you will see later on a little bit more as G930, G920. At this point, this is just like a 4-axis, like a blade, and it will be like spiral roughing, create a 4-axis milling operation that spirals continuously along the reference axis. Ideal for single blade roughing. It is a highly productivity cycle suitable for hard materials and capable of high chip removal rate. During machining, the tool remain in a plane perpendicular to the rotation axis for axis machining for greater rigidity and of the machine tool. For each cutting pass, the tool remove all the material around the model before execute a lateral step over along the reference axis the next cutting pass. Roughing passes can be constant offset of the model surface or the shape. The passes can adapt between the shape of the stock and the model. So means I use this on an M5, which at M5 it's a true 5-axis machining, but you can do this on any machine like M70, L20, L32. You can use that strategy for any machine. So the next one, now we're jumping on composite 5-axis machining, and Spree has pretty much like 6 strategies, and I'm been using pretty much, well, I still have to use I think 2 more. They're pretty cool, and I gotta say this is made off of Spree. Uh, but you can use any other software. Just you got to make sure that you got the right post processor. But you got to work with them. But it's not just I'm just using a Spree. You have to use Spree. You can do that with many other softwares. So the composite cycle streamlines programming of the complex part by allowing the programmer to combine 6 different machining patterns with 5 different tool orientation strategies. Unlike 2 machining cycles, which utilize 2D geometry to define the part, freeform cycles require 3D CAD data, including surface or solid model. It means, I gotta say, probably you can do something like 5-axis just using 2D, but it will be kind of like a hard instead of having a 3D model like a SolidWorks, XD, some solid. It will be much easier to get here. All you have to do is just click against the surface, and obviously you got to set some parameters on Spree, but the software will take care for you. Moving forward, so this is the G920 5-axis machining, TCP, which means tool center point. So basically we just cut this part here. I'm going to show you at the end the whole video cutting in real. So composite create a multiple milling operation from user-defined combination of toolpath patterns and tool axis orientations. It can be chosen from 6 machining patterns, as I say before, and 5 tool axis orientation strategies. The shape of the toolpath and the orientation of the tool axis are defined independently from each other, giving the user the creativity to compose any complex 5-axis or 4-axis function with some limitations. The 6 patterns that Composite have is parametric pattern, project parametric pattern, project spiral, parallel plane intersections, plane intersection with spine curve, and contour offset. Contour offset, that was the one in my previous presentation. That's the one that I did use for the globe, and I believe many people will remember that globe on one of our shows. At this time, we use a project spiral for this one, as you see, and it will be pretty much a long code. So I use the SD card, reading off the SD card. So I'm going to move forward. This is a Spree, and like I say, this is made of a Spree, but if you have a different software, I believe, and I know it can be done, doesn't mean not Spree, it's just need to work a little bit with the software and the post processor and get the right code. It's just that. So um, G920, G920 again, 5-axis machining, TCP tool center point. In the M5, at the same as the D25, as soon as you get to the G920, you will notice in the screen or the control, it will say like tip work. So tip work means you are under G920. It's just that. The part that we make, and you see already some videos over Spree doing it in the simulation file. And basically this will be my main program, as you see, calling up tool 12. I'm kind of using rapid fit setting down, just get it down the rapid fit settings. I'm using a variable just to define my fit rate around the fixture. As you see here, G920 need to be specified the 5-axis. If not, you're gonna get an alarm. So if you can count, you got X, Y, Z, B, and Z. And like I say before, because it will be a lot of lines, so I read off to the SD card in this case. So in this machine, to do that, so M98 P102 will be the subroutine number, comma D2 will tell them when you get here, will tell, all right, read this subroutine of my SD card, external memory. So once you finish the control finish reading that subroutine, then I will cancel G921, go away, retract, cancel my rapid fit settings. And because this was a lot of milling, I will suggest all the time not shut down the spindle, just leave it on at low RPM and keep doing other stuff instead of just on off, and then canceling my my offset. That's usually what I like to use. This is G920 again. Then in the back side, I didn't use on this part, I didn't use G920. I did use G930 inclined surface machining. And in the back side, when you use the B axis, you need to first go G910 independent B axis and flip to 0. If you just go to that line without having the B axis at 0, it will behave and it will actually alarms out. So this is the format that I use even in the M70 control for the back tools on the B axis. So you first need to call up G910 B0. So once you get here, as I showed you before on the G920, it will say in the control, incline, same thing on D25. These are very specific codes for the B-axis work. This is just to show how the machine just expressed to you. And modal page, it's so powerful that I really, you pretty much any programmer know that that's where you need to read where you go, how much you remain to go on each block. So this is, you need to read all these things to get the part done properly. Don't program and speed out the code in Spree and or any software. Always just go carefully and line, check the screen. I think that's the way it is. So G930, again, in client surface machining, you will notice at the control when you are on that G code. So basically, this is the part that I just decided to make on this presentation. And like I say, I made it off M532. So I'm gonna play the video. The video, it takes a little bit, and as you see, this is just to show B-axis work. I have done nothing with the turret. Probably later on I will add some fixture with the turret, so it will be pretty much made better example, but this is just to show B-axis work. So now I'm just turning and kind of like back turning and the front side, just doing one for the mills, turning on the back side. So I'm gonna try just to crank a little bit because this is a long video. As you see, I
Hey,
went
Ray,
first.
you might want to turn up the volume on the video as well.
It's off.
Okay.
It's off already. So basically, we're doing like a G930 pretty much on all the fixtures. G930 and 920 has to be in diameter. And like I say again, in the software need to be communicating properly. Specific, if you're doing G920, there's two parameters that I did cover on the first presentation, and it will be like a rotary axis parameter, 7908 and 7911. So if you had both at 0, in the software need to say fix it. If you got 1, gotta be rotate with the part. If not, it will behave very funky and you can crash machines so easily. So all the G930 here, actually I'm not cutting in real. I just decided to cut like air, because that way I can record the video and not having much ships around. So this is just, like I said, for the presentation, and I will hope that you enjoy and see that all the things that can be possible made of any of our machines. Not so hard, but for this one, obviously I will say you need to do it with the software. So many codes, so many lines, many complex shapes, and keep going with the shapes. It's like using like profit milling. I'm gonna move forward a little bit, and then I go 0 and make some other fixture. I believe it's doing like a face, just milling some stuff. Then I think it will just drill, pretty much just deburring the whole stuff. Also, you gotta look, once you use anything on the B-axis, you will see the tools stick out. So you gotta watch for that, because you can hit the cap knot. So basically, it finished on the back side and it's coming over the main side, and I start like roughing and have less material for the ball mill. So pretty much that's what it's doing. And for this one, I'm using all way, I will say G910, This program that I just made, I think it will be a good example for many people. It has all the G code, like G910, G930, G920. So there's all the G codes on this program. And now it's just drilling. They're drilling. It made off the G930. It's just this one. It's pretty simple to make handy. It's just you need to know where is your datum of the fixture and command G930 where you want to go in Z, and that's it. That's simple. That can be made off handy. But now this one is it's using the spiral roughing that we speak before. And basically you can do these on any machine. This is just more like a 4-axis. It's going up and down. It's using X, Y, and the Z, and kind of like a step over in Z. And it's just roughing. Keep roughing. It's a lot of material. I'm gonna go forward because long, and then just go back, clean them up with the turning tool. And now this one is using G920. You can use G920 as kind of like lockdown at 90 degrees, but I know this is using G920. Just cleaning, finishing the face, so that way you don't have like a step on that face. And then this one is the real 5-axis. Then this is the beauties of the G920 on our machines. And as you see, the B-axis is going kind of like I don't want to say crazy, but to me this is beautiful. Just to look, I can be the whole day just looking at this, and I enjoy so much. Stop the machine, check the surface. I really enjoy doing this. So basically G920, this was the one that I just showed you before. This is read off of this SD card. And like I say, it's a huge code made of the software. I will think so difficult to handy. I don't think that's possible, but so it's going around all that surface and looks pretty cool. Surface, I believe I'm doing like a step over of 5,000 something like that. And the finish came up so nice. I love it. So I'm gonna move forward a little bit. This part, it's I can crank a little bit more and do it faster, but then this is for like a training or presentation purpose, so I just want to be able to go and record nicely. And you see the B-axis just flipping around and moving up and down, so pretty much 5 axes moving all at the same time. Beautiful. So you see, I like pretty much at the end of the video, and kind of like almost touch the side of the tool, but it's not. I just stop it, and it's awesome how the software let you go that far and up. It's good. It's good to have these. It's good to know how to do these. So I will say, getting there. I don't know if I can stop. Let's see. A little bit more. Whoops. So now it's kind of finishing. Finishing and going up and down. So guys, this is real or true 5-axis machining in the Swiss world. And you see, I'm just trying to get to that spot that the first time I really was, oh my God, this is gonna hit. No, it's not. It's not. So you see how it's moving. I love it when I check this. It's, to me, this is like a kid being in Disney. Look at that. How beautiful looks that. Oh my God. Awesome. Perfect. So basically it's almost finished, and the last process will be pretty much doing like the flat. Pretty much it's like a hex, 6 flats, and that's all I have for you guys today. Yeah, this is the flats, this is the hex, and basically we're done.